Hi, welcome to Chapter 1 of Java Programming. In this discussion, we're going to cover some basics of Java, show you a little bit of programming, and just kind of get you oriented to how to program. I understand this class may be the first programming class that you've taken, so you may have some terminology questions, and we just want to make sure we get through all of those. For some of you, this may be a lot of review, and that's okay. Sometimes reviewing those terms are going to help to cement them. Let's get started. So first off, our basic terminology. When we talk about programming, we talk about software. So the difference between hardware and software. Hardware I generally look at as something tangible, something hard, like your computer, your monitor, your keyboard, your mouse. These are things that are tangible, they're hard, as opposed to software, which is not tangible. This is something that you write and then run. So this would be your Microsoft Office programs or your browser program or any type of software. In this case, we're going to be building software out of Java. So we're going to be creating software. When we write code, we have to follow some sort of logic or some sort of algorithm that's going to describe how to solve our problem. So whenever I use the word algorithm, that simply means the program flow or the program set of steps to get you from point A to point B. How are you going to get something done? When we write software, we generally can compile it into machine language or binary. So the computer is going to read in bits, zeros and ones, and you have to get the code from print hello world into zeros and ones. So we do what's called compiling it or interpreting it depending on which language you're using. That is going to take those codes, so your print hello world, and it's going to break it down into your machine language using a compiler. You're going to hear the word compiler a lot. When we talk about different levels of programming, we can have what we call low-level programming, which we write in assembly, versus higher-level programming, which is writing in code, like in Java. Most programmers are going to write in a high-level program. That doesn't mean people don't write in assembly. It's just that it's not as common. You can write in assembly. You can use, your move and your registers the same way you would with assembly. You just don't have to because the compiler will do it for you when you write it in a higher level program. When we talk about leveling a program, we're actually talking about the level of abstraction from binary. Originally, people would actually write in binary because they would get it into zeros and ones, and that was ridiculous. So we moved on to writing assembly language, which at least was able to be converted down into the zeros and ones, but you didn't have to write it in zeros and ones. After assembly, we started building higher level programs that did the work for you, and then they were compiled down into assembly and then down into binary. When we talk about the syntax of the language, every language has their own syntax. The syntax is kind of the grammar rules that tell you what you have to do. What is the formula that you're going to use for how to write your functions? Are you going to put a semicolon at the end? Are you going to use this keyword or that keyword? Are you going to be using capital letters, lowercase letters, variables, so on and so forth? Strongly typed, weakly typed. Those are different things that go into the syntax of a different language. If you've ever learned a different language, French, Spanish, Latin, any other type of language, you know that the first thing we talk about is our syntax rules for the language. Do the nouns come first or second? Do we conjugate the nouns, the verbs? How do we change things as we go along? Do we put our adjectives before or after our nouns? These are all syntax rules, and we have the same kind of thing in programming. So in any programming language, you're going to have your syntax rules that are going to tell you how to write the program. In Java, we use a series of statements or commands. Most languages do. We're going to say print this, do that, set this value equal to this, change this, maybe do a loop or something like that. But you're going to have a series of statements, and each of those statements in Java is going to end in a semicolon. Really important. That's part of the syntax rules that we use. Again, we talked about compilers and interpreters. Debugging is the concept of being able to look at your code and figure out what you did wrong. There are different types of errors that you can find in your code. You can have syntax errors, which is where you did the syntax wrong, and you can have semantic errors, which is where your logic is broken. If you said, I want to put the peanut butter and the jelly on the bread, but I don't have any bread, that would be a logic error. It might run, you'll just get confused when you get into the code because there's no bread to put the peanut butter and jelly on. So a semantic error is something broken in your logic. You forgot to do something, or your logic was broken somewhere. Those can be a little bit harder to find because the code will not always crash for you. It may just give you the wrong answer. You may have multiplied instead of added, and your 2 plus 2 and 2 times 2 came out to the right answer, but your 3 came out wrong and you weren't quite sure what you did wrong here. It might be something in your logic. So the act of debugging is being able to look at your code and figure out what you did wrong. Sometimes the compiler will help you with syntax errors. It'll usually tell you what line you broke, maybe even give you some description of what you did wrong, which is nice. So being able to understand those debugging rules is a big part of being a programmer. The flowchart that's over on your right-hand side is simply your debugging process. So you are going to plan your logic. I am a big proponent of write down your logic ahead of time. Write it in pseudocode. Make sure you scribble something out before you get your hands on the keyboard. Sometimes people, let me rephrase that, most of the time, programmers want to just get started. They want to sit down at the keyboard and they want to start typing. The problem is if you don't think it through, that's kind of like I'm going to get in the car and start driving, but I don't know where I'm going. Well, if you don't know where you're going, how do you know you're going the right way? So it's really important for you to plan your program logic before you start, even at a minimal level. What kind of methods are you going to have? What is your basic algorithm? How are you going to get from point A to point B? Make sure you start thinking through, because as you're planning your program logic, you're going to find things that you need to resolve that you may not have found if you just started coding. Once you plan your program logic, you're going to start writing your code, and then you're going to see if it runs, if it compiles. Can all the statements be translated into machine code? This is where the compiler will tell you about those syntax errors. No, you forgot a semicolon on line 22. No, this is not the name of the function. I don't know what that function is. You wrote a function name wrong. You spelled it wrong. You can then look at those errors, then go back and fix your code. Once you fix all of your syntax errors, now you can start running the program. Here's where you find your semantic errors, runtime errors. These are errors that you find while you're running it. These could be logic errors. These could be basic errors. They could crash your system. They could choose not to crash your system and just give you the wrong answer. You have to run it multiple times before you can say it's done. One of the problems that I found with a lot of programmers that are just starting is they will write the code and they will submit it to me, but they won't check it. They won't run it multiple times. If you turn in code to me that does not compile, I know you didn't run it, which either means you copied it from somewhere else or you just didn't bother. And I'm going to give you a 0 for uncompiled code. If I run your code and it basically works, but there's a couple of little syntax or semantic errors, I'll just tell you, I'll mark you down for the semantic errors because I know you didn't test it well enough. You need to test your code. You need to run it 20, 30 times, making sure that every different version is going to work right. So these are things you're going to be doing with your code, especially in this class and in any class that follows. Basic comparison between what we call procedural and object-oriented. Java is an object-oriented programming language. So in Java, we create classes. In a procedural language, similar to Python or a couple of other languages that you may have already used, you simply can create and set variables and then have some methods or functions, but you're not using object-oriented. You're not creating classes. So you can create those procedures and just run it linearly. So it goes straight from the first top to the bottom, running methods or loops as necessary inside. When each operation is called, the logic is put on hold and executes the commands. So if we're running procedurally, you start at the top, you go down. If we run into a loop, it stops and it runs the loop until it's done. Then it keeps going. Then it runs into a function and it stops and it runs the function and then it keeps going. And you have a basic procedural linear going straight down. With object-oriented programming, and yes, you can write objects in Python. I didn't mean to imply that you couldn't. Object-oriented programming, you're going to create classes. We can call these objects, we can call them classes, we can call them anything you want, but they are an actual tangible object that we are going to be manipulating. The basic concepts that fall into object-oriented programming are encapsulation, inheritance, and polymorphism. 3 big words. Encapsulation simply means we are going to encapsulate, put into a capsule, the concept of all of the methods. Everything is going to be inside the object. We do not have methods outside of our object. We don't have functions outside of our object. The object is the thing doing everything. So everything is object-based. You have an object and you run methods on that object. You will see when we start looking through our code that everything starts with a class. Everything starts with an object. Even if you're running procedural code inside of your object-oriented language, you still need to call that object and tell that object to run. Inheritance allows us to take a class and make a subclass from it, to have a base class and a derived class. So a superclass and a subclass. There's a lot of different ways we call these: parent, child, class. And this is going to allow you to write one piece of code for the base class and then have multiple subclasses off of that that may have extra pieces of information in them, but they still are pretty much the concept of the basic. This is where you look at like animal, and then you break it down into canines, and then you can break it down into domestic animals versus wild animals, and then domestic animals you can get down into a breed, or you can have things like that. But back with our basic animal, you can have how many legs does it have? Well, everything has legs. Everything or some things don't. Snakes don't. So we can have animals, and then we can have snakes, and snakes don't have legs, so their number of legs is 0, and we could do things like that. So the ability to inherit the properties and the attributes of your superclass or your parent class is another concept in object-oriented. The last is what we call polymorphism. Poly meaning many, morph meaning forms. Many forms. We can have the same method called in many forms. Each of the different subclasses can have their own version of that method. One of the main methods that we use is the toString method, the ability to break your code into a string so that you can have your class. I can have a student class, and every time that I want to print the student, I want the first name, last name, and then in parentheses, I want to have their grade or something like that. That could be some version for a student, but if I had a teacher, I may want to have their last name first, and I can write a toString method for that person that uses a different form. They can have multiple forms and still be the same method, toString, so that I can call it on either of the two functions, or either of the two objects. I recommend a lot that you go back to the chapter and read this section if you don't understand the difference between procedural and object-oriented. There's a lot of information in the chapters that goes over that. So let's get started on Java. So Java specifically as a language, everything I've talked to you up until now is a general overview of programming. This could apply to C#, this could apply to C, this could apply to C++, Python, F#, Pascal, any other language. Anything I've said before kind of can fall into those concepts. Now, Java specifically. Java is object-oriented, as I've said. Java is architecturally neutral, which was a huge thing when Java came out in the mid-90s, because it could be run on any operating system or device that had a Java virtual machine installed on it. So you could write the code once, and you could use it on your Mac, and you could use it on your PC, and you could use it on your Linux machine, as long as that machine had a virtual machine on it. So you install the virtual machine, and then it could run the same code anywhere, which was a huge aspect of Java, which made it great. You could use Java no matter what your platform was. You are going to write the source code, so your basic Java source code, which ends in a .java, Java. Then you use the Java compiler, which is going to compile it into a class file, .class, because everything is an object, everything is a class file. That can be interpreted by the Java interpreter inside the Java VM. So the Java VM is going to interpret that and be able to run it. And then whatever operating system it's on, it will know how to run that there. Java was originally modeled after C++. So if you have done any C++ programming, Java will make a lot of sense. If you understand Java, trying to learn C++ will make a lot of sense because they're very similar in their syntax and their semantics. When we use Java, we can use them for applets on web pages, or we can create Java applications, which are standalone exe files that you can run, or executables depending on which language you're in. So we can run either standalones. But Java was really a big deal with web pages. Being able to run Java applets on your web page was part of what was really one of Java's things. By the way, important thing to keep track of, Java is not JavaScript. JavaScript has nothing to do with Java. They are two completely different languages. Don't think that they're similar. They're not. They're different. Java is a compiled language that is run with a VM. JavaScript is a scripting language that is interpreted by your browser. Two totally different languages, different syntax, different situations. Okay. Let's go look at some code real quick, and then we'll come back to the PowerPoint. When you open Visual Studio Code, you should see a screen that looks similar to this. It's just going to have your untitled, because I have no folders open. This bar might be open here. If you use a folder frequently, it should have the previous folder that you have. You can also use Git if you have the right extensions installed. You may not have all of these across the side like I do. I have one for Azure, I have one for Git, I have one for LiveShare. So you may not have all of those. That's okay. If you need to add some extensions, if your version of Visual Studio Code doesn't come with the right extensions, you can click this button that looks like a Tetris box and see which extensions you have installed. You can type in Java and make sure that you have your Java extensions. The ones that I have are the Java extension pack. I have Maven and I have a test runner. You don't need those. If you want to have a project manager or a debugger, you are welcome to add those as well. So these are the different extension packs that I have for Java for this course. You really just need Visual Studio Code to know what Java is. And as long as you have the Java installed, you should be fine. So what we're going to do is I'm going to open a folder. And in my case, I'm going to have my CSCI 111. And then inside of it, I make a folder called code. And that's where I'm going to store all of my code for this course. It's going to allow me to keep things straight. And that's just going to have a folder, and there's nothing in it right now. Right now it's just completely blank because we're going to be adding code as we go along. When you open a folder, in this case it says code because that was the name of the folder. If your name of the folder was Goober, that would be fine. But I'm going to show you what the first file would look like in Java. So I'm going to create a new file, and I'm going to call it first.java. Okay, the .java is going to tell Visual Studio Code that it's a Java file, which is why this down here, which told me what language I'm writing in, is Java. It just changed from Untitled to Java. And the class that I'm going to be making is called First. I'm going to be making a public class called First. It's really important that your class name and your file name are the same name. So you notice this was First and this was First. Because for this purposes, I'm going to call it the First file, which is fine. Once I get into my file, I need to create the class for that file. And then I'm going to create a main function. This main module made function is a pretty consistent thing through all of your classes that are being used procedurally rather than object-oriented. And we'll talk about that a little bit more as we go along. In this case, we're going to do public static void main. Now, I'm going to explain all of these in the next slide, explaining what each of the different things mean. But for the purposes of right now, public means that it's available to anybody who can see the class. Static means that this is not going to change. Void means that it does not return anything. And main is the name of the function. We always have the same arguments for a main function. It's pretty consistent. If you use a Java emulator that is not, if you use like Eclipse or something like that, you can have it create your main function. It will always have a string argument. If you remember back to command line arguments, command lines always took a series of strings that came after that. That's what this is doing. This is a command line argument where if I ran this in a command line and I said call the first function or the first class, it would look for that string argument. In this case, you have to pass string arguments even if you're not going to be passing anything as arguments in this case. And then we're going to print out our first line of code. So we are going to use our system out. You'll notice as I'm typing that Visual Studio Code is going to kind of help me out. It gives me IntelliSense to help me find the different words and the different functions that I need. So inside out, I'm going to do println, which is print line as opposed to print. You can do both. And you can see it's given me about 7 choices here of whether it wants to print nothing or whether it wants to print a Boolean or a character array, which is a string, double, float, long. In this case, I'm just going to put in a string. First Java application. Big important thing with Java, semicolons.
If you've heard anything about programming, you know that semicolons can be a big deal. So, semicolons at the end of every statement. It tells the compiler that you're done and you're ready to go into the next statement. That's the end of the statement. So in this case, I have my class, which is public, meaning it's available to everything. It's a class, which is fine because it's a class file. We needed that. And my main function. Now, you'll see in my Visual Studio Code that I have these two things up here called run and debug. They popped up automatically. I didn't type those. Those automatically came with the IntelliSense, and they're going to let me run the code by clicking the run button. They will do this for every method or every function that you create. They'll give you the option of running just that method. You can also come up over here and hit the run button here, or run with debugging. So run and debug. You see the little bug. He's a little bug. Same little bug that's sitting over here. So in this case, I'm going to go ahead and hit the run button. When I hit the run button, it is going to open up a terminal. Let me move that down so you can see a little better. It is going to open up a terminal. And this terminal window, in my case, it has a couple of options. I have my problems, my terminal, my output, my debug. In this case, it's just the terminal that I'm going to be looking at. It's going to list out what is the name of the file that you went into. And in my case, it's very long and very irritating. And then it has where is the Java exe file and where is the other code file once it's compiled. You can ignore all of that. So from here up to here, from here up to here, you can ignore this. This is just something that's going to print out every time that you run something in the terminal, and that's fine. What you can see though is that it did print first Java application. If I wanted to change this into my first Java application, I could just come up here and hit my, and then click the run. And you'll see that now it says my first Java application. When you hit the run, it automatically tries to save for you, or at least I have mine set up that way. If yours is not saving, make sure you save frequently. If you change a file in Visual Studio Code, it'll pop up with a little dot here telling you that it's changed. In my case, there's no dot because it's automatically saving as I go along. So again, I can come up over here and hit run. That'll do the same thing, and it'll say first Java application. First example of your code.
So we just looked at our class first that had our first Java application. Just to run through it again, just to make sure you understand, we called our class first. The class name is first, which means the file name has to be first. Make sure that they are the same capitalization and they are the same name. If you name your class something and your file name is different, the compiler will get confused. Every class that has a procedural method needs to have a main function. The main function is going to allow you to run this class on its own. If it was a class without a main function, like it was a dog class or a fruit class or something like that, it doesn't have a main function. It doesn't do anything on its own. You have to call instances of it. We'll talk about that in a few minutes. So our main method or main function, I'm going to use the words method and function interchangeably. Some languages, functions are something that return a value, methods are something that doesn't. It's up to you how you want to see it. I find that having a hard and fast rule when it comes to the terminology is not always the best thing with programming, because some languages may have methods that return values and they may have functions that don't. So I don't like to stick to that one. Parameters, just like in math class when we had our f of x, parameters are pieces of information that you give into the function, as we talked about. In this case, your main is always going to include a string array, which is the brackets. They're square brackets, not curly braces, and not parentheses, square brackets. A string array with capital letter string, because the string is the data type, and we call it args. This is a pretty consistent thing if you're going to be running your procedural code in Java. Again, when we talk about our class methods, we'll talk about those a little bit different, but we're going to be procedurally running down this code. It's still object-oriented, don't get me wrong, but we're going to be running down it in a linear fashion. And then printing out to the console. As you saw, we printed out to the console, and we could use our print line. There is a print method that does not print a line after it. You can write two print methods, one right after each other, and you will get 2 lines printed. So you can practice this printing multiple options. You're going to be doing that in your homework, by the way. So before we go any further, I want you to stop the video and I want you to go do this. I want you to write your own hello world. I want you to open up Visual Studio Code or whatever your emulator is or your environment is, and I want you to create your first .java. You can do it in Notepad if you want, but I'd recommend you get started in Visual Studio Code. You can copy word for word off of the screen right now. The public class first, curly brace, so on and so forth. In Java, couple of rules that you want to keep track of before you get started. Everything is case sensitive. Capital P public is different than a lowercase p public. Everything is case sensitive. So make sure you keep your cases straight. Every open brace needs a closing brace. If you've done any HTML or if you've done anything that has an open and close concept, that'll be really easy for you to remember. Every time you open something, it has to close. So open curly brace, you need to have an open and a close. Every statement ends in a semicolon. If you forget your semicolon, the syntax errors will come up and you will get yelled at. White space is generally not important. However, make your code readable to the next guy. Don't be a turd about this. So if you get to the end of your line, put in a new line and keep going. And you can do that. White space is irrelevant to Java, but it makes it easier for you to read. If you have 46 characters all on one line and you have to scroll over to find them, it makes your code harder to read. Don't do that. And make sure that when you name your file, that your file is the same as your class. So in this case, my public class first with a Java extension. Always use the Java extension because that will allow you to compile it and run it. All right, go have some fun with this for a minute. You're just going to play around a little bit, make your first class, make sure that you can do it and it compiles. And then come on back. So hopefully you ran your code and it worked, understanding a little bit about compiling and syntax errors. After you finish writing your code, you always have to compile it to convert it into the JVM. In Visual Studio Code, it compiles it for you when you hit the run button. The run will compile it. You don't have to manually compile it. If you are using Eclipse or some other editor, you might have to run it or compile it using the Java compiler function. Just like in a command line with a C prompt, you can type Java C space and then the name of your class.java, so the file name, and it will compile it into a Java or a first.class file. Once you do that, you can run that file. So if you are using your own machine and you have not installed Java, you need to make sure you do it. Install the Java VM on your machine. If you use Visual Studio Code, it'll probably prompt you at this point and say you need to install Java, and it'll take you to the right place. If you're using Eclipse or one of the other ones, it should have already installed Java for you, so that should be in there. If all else fails, so you tried to run it and you couldn't get it to compile, you can always use an online Java emulator now. You will not be able to do this after Chapter 2, so we really want to make sure that those get fixed. If you haven't gotten it working by the end of this lesson, make sure that you somehow contact me and we will work through it. When you are running your code, you will find syntax errors instantly. You'll go to run it and it'll pop up and say syntax error. You forgot a semicolon on line 3. Cool, go fix it. Correct your syntax errors. Go ahead and run again. Don't think that forgetting your semicolon is somehow makes you a bad programmer. Everybody does it. Everybody forgets a semicolon every once in a while. The important thing is when the syntax error pops up and says you forgot a semicolon, can you go fix it? The important thing of being a programmer is not the guy who can program everything perfectly the first time. A good programmer is someone who can program it, run it, find his own errors, and go fix them. That's a really important part about being a programmer, the ability to debug, the ability to go find your errors and understand the debugging process and move on. In this case, we're going to show you what the command prompt would look like. So after you get it to compiling correctly, you would compile it using that Java C, and it would create a first.class. You then tell it to run using Java. Java tells it to run, and then just the name of the class. You do not include the word class after it. It is not Java first.class, it's just Java first. It knows it's a class file. Java is looking for a file that's called class, that has an extension of class. It's looking for the word first. What is the name of the class? So if you're using a console, you type in Java first, and then it'll run your first application. If it runs correctly, it should look like this. If it doesn't run correctly, go back and fix it, and then come back and do this again. I'd like you to take a few minutes when you're finished with this video to just play around with your code. Do the print, add a second print line, resave, recompile, rerun. Keep doing this. If we were in a class right now, I would make you sit there for 10 minutes playing around with writing code, writing print statements, changing things around, and seeing if you understand what goes on. So I'd like you to do that. And then, but if you wait for a few seconds, we'll just finish up the video, and then you can do that until you're ready to get started on your homework. So, basic comments. In the real world, probably the most irritating thing is when someone else's code is now your job to fix. You have to go fix their code. So somebody wrote code, company was using it for 5 years, then they hired you to come in and fix it. And you took one look at their code and there's no comments. Please, comment the crap out of your code. Seriously, over-comment. I've had some people over-comment. You don't have to write 3 lines of code or 3 lines of comments for every line of code, but you do want to write comments. What are you doing here? What does this variable mean? Why are you doing this? What is the logic? What I actually do in my code is I start with comments. I comment my algorithm. So I write out my algorithm in comments before I write any piece of code. So I can say, this is what I'm going to do first, this is what I'm going to do next, this is what I'm going to do third. Then I go back and write the code, but at least now there's comments in there, so everybody knows what my logic was. Different types of comments in Java. Java offers you 3 different ways to comment. You can do a single line comment with 2 slashes. This is going to allow you to just comment this single piece of line after your code. So you can do this in line. So if I wrote print ln hello world, I could do // this is my print statement, which is great because they're just in line. You can do block comments, which is /*, //. This is the slash that is next to your shift key, not the one above your enter key. So this is a /. And this is a comment from the beginning to the end, the same way as if we put curly braces around it. It's a block of comments, so we call them block comments. And the last is what we call Java.comments. These are kind of the best comments in Java because when you have IntelliSense in your code, your Java.comments come up when you mouse over a function. That means if you use Java.comments in your functions or in your methods or anywhere, honestly, in your code, but definitely in those functions and methods, they add this IntelliSense. So if someone else tries to use that method, it pops up with this little comment that you wrote. If the comment says this function takes this as a parameter and takes this as a second parameter and then gives you this as a return value, it's really convenient for the next guy who tries to use your code. So I highly recommend trying to use Java.comments every time that you write a function or a method in your code. Top of your class declaration, any of your public methods inside of your class. So these are your different class comments. Okay, we are going to do a little bit on GUIs. In the book, we introduce the concept of swing. Swing is technically not until chapter 14. It's the last chapter of this class. But we're going to slowly introduce swing concepts as we go along. Swing is the GUI version for Java. It's the GUI version for Java. So we can use this to make things that look like regular windows. We can have input boxes. We can have buttons. We can have a box that pops up and says hello. And it's a GUI, G-U-I, GUI. And just gives you a quick version of that. You can see the code in here. The code is also in your book of being able to import the swing object. We have to import it. We haven't talked about importing, but we will. So you can just copy word for word from this, and then we'll talk a little bit more about it. And we can use the method show message dialog just to be able to pop it up, and then we give it a location and then what text we want to put in there. Just a quick version of, I'm going to actually start making windows that pop up on my screen. A couple of don't forgets. So first off, file names and class names must be the same. The difference, parentheses, curly braces, square brackets, and angle brackets. We call them angle brackets. You might think of them as the tags that you use for HTML. Don't forget to end your block comments. If you start with a /*, you have to end with a //. If you're using VS Code, it should be color-coded to be a comment in green or whatever color coding your theme is. And that way you'll know everything is commented. Don't forget to end your comments. Java is very case sensitive. Remember, capital letters and lowercase letters are different. Semicolons at the end. Don't forget to save. Don't forget to recompile if you're using and emulate, if you're using the command prompt. And don't panic if you see error messages. Just because you didn't write it the first time doesn't mean there's anything wrong with you. It just means you didn't write it the first time. So go write it better. Go fix it. Go fix whatever the errors were. The more you fix your own errors, the better programmer you will be. The more you ask me to fix your errors, the less you will be dependent upon your own ability and more you're dependent on mine. That doesn't mean I won't help you. You can go ahead and call me, or not call me, send me a chat on Teams. If you're getting errors you can't fix, you can't find, go ahead and send me a chat on Teams. But don't panic. Don't worry, oh my gosh, I have 14 syntax errors. Yeah, they're all because you missed a semicolon on line 2. Now you're fine. It happens. More importantly, don't think that just because it compiles that it works. It may not. You have to test it. And this is where your grading is going to come in. I hope you got some out of this chapter. Again, don't forget this doesn't make up for not reading the chapter. It just goes through the chapter. So hopefully you understand things. Remember, assignments are due. Turn them in. Give me a holler if you need anything. If you're seeing this on YouTube or something like that and you can't get hold of me, go ahead and put a comment in the chat and I can respond to those as well. Have a great day and I'll see you next time.